68-degree air temperature. Return it through the crack unit, and then just simply use our crack unit as an air handling system. When we are running on the economizer mode, we have an exhaust fan that has variable speed drives through it, that when the air comes up into the data center room, pulls into the cold outlet, and is sucked through the servers into our hot outlet. Hot air then returns back into the plenum, and then is exhausted out into the atmosphere with all the filtration that's required and all the fun stuff out on the Colorados. And then we can basically manage any kind of combination in between the utilization of the crack unit and the outside ambient air temperature. The fortunate thing is, again, at the hottest day, we still don't need to use the crack unit in condenser mode. It's there. It can be used, but we don't have to turn it on. So we have a semi-sophisticated PLC that manages all this, measuring outside ambient air temperature, inside temperature, measures the differential pressure, measures the humidity inside and out, and then controls the whole combination of crack unit and economizer. Any questions on that? We'll have questions at the end as well, so feel free to
ask a question. Yes. How do you control the pressure if something's out of whack?
So basically, from both the supply side is a variable speed drive and the exhaust is a variable speed drive. So the difference is just in the pace at which it allows things to come in and expel. That's how we, with the combination of the servers in each row and the pace at which they're pulling air through, we're able to measure and control that pressure.
Is it supposed to be close to zero?
I'm not super exact on that. I think it's somewhere between 0 and 1 or something. I can definitely get you that information.
Okay. Is this something you all do? Is this something PLC control system? Is this something your HVAC vendor do?
So we have done it. We basically took this product, this Colorado product is not a data center quote unquote product. We kind of made it a data center product. It's fortunate enough that it has the filtration system capabilities that you need for a data center. But the PLCs, we had to hire somebody and tell them exactly what we're trying to accomplish. So from my perspective as the president of the company, the most important thing is what's the payback and how much does it save me and does this make sense? Day one, just looking at a 12.5 kW cabinet 20 cabinet pod here, we're able to save $12,000 a month. I'm sorry, annually on this small piece of pod infrastructure. The cooling actually is a 2N. We compared that to a traditional crack unit, which would run at 32 kW per month in the winter, 37 kW in the summer. You can see the dramatic cost savings that this thing is able to do. Because we designed our facility in the cooling capacity in a 2N fashion, the payback is immediately. There is no incremental cost to implement a Colorado system than there is to implement a traditional crack unit system. The other key piece that is obviously another one of those super big buzzwords in the data center industry is virtualization. We built our data center from the ground up utilizing virtualization. We have no dedicated, we have very few dedicated customers that don't fit into our cloud quote-unquote infrastructure. And so because we never had the server sprawl, it's quite nice that we can kind of show you some examples of a subset of our servers. Traditional dedicated server model, when you have or in a data center with 100 physical servers, IT power costs about 18.5 kW, while cooling tower traditionally costs 14.8. That's actually assuming they're like 1.9 kW, which traditional and older data centers are 2 plus. Which again, huge payback, super fast. When you look at virtualization, we've been able to fit over 100 servers into 8 given servers with a tremendous cost savings for us, well in excess of $20,000. Kind of the point about these last 2 slides is that you can save a lot of money, have an immediate payback, and from our perspective, we've been able to invest a portion of that back into renewable energy, and then again, be able to give our customers a significant discount. So from a renewable energy perspective, we've looked at most of the types of renewable energy, from solar to wind to geothermal. In our area, we sit in a class cost us about 0.8 cents more than 0.8 period. In our area, that's about 10% more than our local power company, which is about 8.5 cents, somewhere between 6.5 to 9 cents. I think we're looking at about 8.5 specifically right now with the wind that we're purchasing from those guys. And so on-site generation, if you're actually looking at on-site generation, if you're in a wind zone that makes sense, it can actually deliver an IRR, 17% IRR. Unfortunately, only when you equate some intangible benefit to wind. In our business model, there's a significant amount of intangible benefit, and that is not all captured in a 17% IRR. But there are IRRs. Wind will be the only investment we make that doesn't have a 5-year payback. It's literally about a 17-year payback. Geothermal is another option for companies that are looking at data centers and how to cool your facility much more energy efficiently. It has a faster payback when you're in an area that cannot use outside ambient air temperature. Some of the other green factors that we have put into our facility is that we use and try to stay focused on no VOC paints, flooring. We've installed an auto-off lighting system. Again, that auto-off lighting system had a very fast payback period for us. Servers, we use step-down processors in all of our servers, again, just to try to be as energy efficient as possible. Sand infrastructure, spin-down disks. More importantly than the spin-down disks is that we move it off and dedupe it as fast as possible so that we can, again, lower our total operating costs. So we are going to give you a quick live tour. This one is not actually live, sorry. This is a recording from our wind farm about 8 miles to the west of us. That wind farm produces about 72 megawatts of wind energy from 34 turbines. Each one of those turbines is about 2.1 megawatts of energy. How many people have been to a wind farm before? Shockingly,